Okie dokie. Let's move on to our next problem. So in this case, we're going to be dealing with number operations and properties. Okay, last time we were dealing with radicals, irrationals, and rational numbers. So let's get to the question. When solving the equation 4 times or multiply by 3x squared plus 2, you see, close parenthesis, minus 9 equaling 8x squared plus 7. Okay, Emily wrote 4 times 3x squared plus 2 parenthesis equals to 8x squared, okay, plus 16 as her first step. So then the question is, which property justifies Emily's first step? All right, so then in this case, when it's multiple choice, it's good to just read the choices and then analyze the problem. So it says addition property of equality, commutative property of addition, multiplication property of equality, distributive property of multiplication over addition. So we have the commutative, we have the multiplication. That means that when you multiply one side and multiply the other. Distributive, you know, when you multiply by everything, and you have the addition property of equality. So let's analyze this. What do we have on this equation that we don't have on this equation? First of all, here is the distributive property, and I see that it remained unchanged. Okay. Wait, hold on a second. Yeah, no distributive property, but then again, after the distributive property, you have a minus 9. A minus 9. Okay. Then on the other side, I have a plus 7. Look, the minus 9 is not on this side anymore. And the 7 turned into a 16. I wonder. Well, I'm not going to keep you. I'm going to show you something. So I wrote it over here. So what would happen if I was to... Nothing happened here, okay? From the one step to the other. But what happens if I add 9 to both sides? If I add 9 to both sides, okay, we get 4 times 3x squared plus 2, okay, nothing happened. And this negative 9 will disappear, okay? That means that we have the equal sign. The 8x squared, and then 7 plus 9 is 16, so we have plus 16. So what just happened? We added 9 to both sides. We added 9 to both sides. We used the additive inverse of negative 9, which is positive 9. We added 9 to both sides. So definitely, the only one that makes sense is the addition property of equality. What you do to one, what you add to one side, you add to the other. As simple as that. Okay, cool. Let's go on to the next question. As part of Jennifer's work to solve the equation, again, we're dealing with a little bit of equations. We're not really solving equations, okay? It says that she had this equation, okay? Now, once again, the same equation. Given this, she got 12x squared minus 6 equals to 11x squared minus x. What do you think happened here? Well, let's look at the choices. Identity property of multiplication, no. Multiplication property of equality, commutative property of multiplication, distributive property of multiplication over addition. Well, let's see what just happened. So, number 2. Let's see. If I was to use this property, 2 times 6 is 12x squared. 2 times negative 3 is negative 6. Oh, come on, I know what happened. The distributive property was used. So then, my answer would be choice number 4. Okay? Don't worry, you're gonna get a handout like this. Alright, let's move on to problem number 3. So, what does it say? It says the following. When solving the equation, and we have this equation over here, you could look at it. Okay? It says Evan wrote the following. 12x squared, okay, minus 7x, nothing changed, equals 6, okay, minus. But now look, the parentheses disappear, and the 2 became 2x squared. That means that 2 times x squared is 2x squared. 2 times negative 1 is, sorry, negative 2 times negative 1 is positive 2. So doesn't that look like this prop? Yes, distributive property. Okay. Alrighty then. So we're done with numbering operations, and we're gonna move on to something else. It says the following question says the following. Okay, graph, and we're gonna start with graph and statistics. And basically, it says the following. It says, Christopher looked at his quiz scores shown below for the first and second semester of his algebra class. And we have semester 1, semester 2. Which statement about Christopher's performance is correct? 1. The interquartile range of what? Interquartile range for semester 1 is greater than the interquartile range of semester 2. The median score, the mean, the third quartile. Okay, you know what? That's it. I'm going to stop right here because I need to teach you something. Or I don't need to teach you something. I need to go over something. So let's start with this. Let's go over, even if you know what, then you could just skip it, okay? But I want to go over the following. Mean, median, and mode. It says, find the mean, median, and mode and range for the following list of values. So we have 13, 18, 13, 14, 13, 16, 14, 21, 13. So what is the mean? The mean is the average. Okay, the average. What is the average? Well, how do you obtain the average? You add all the numbers and you divide by the amount of numbers. So in other words, you're going to add 13 plus 18 plus 13 plus 14, okay, plus 13, again, my God, plus 16 plus 14 plus 21 plus 13, okay? And you're gonna divide all that by the amount of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers, so we're gonna divide by 9. So I'm gonna give you like 30 seconds so you can figure out how to do it. You got it? Well, if you are doing it by hand, of course, you're gonna have a little bit of a hard time. So I'm gonna show you how to do it on the calculator on the TI-84 plus CE. Okay, so the first thing is that we are going to, a division in the calculator could be with the division sign right here, okay, or with the fraction. I'd rather use the fraction so you could see the whole thing. So I'm gonna press alpha y equals, you see numerator over denominator, you see that? See that? So then I'm gonna click OK or enter. And now on top I'm gonna write exactly the numbers. So let's see now. 13 plus 18 plus 13 plus 14 plus 13 plus 16 plus 14 plus 21. And now on the bottom is the number that you're going to divide by, which is 9. And you got 122 over 9. So the mean, okay, the mean is 122 over 9. But of course, not all, they're not going to want the answer as a fraction, right? They might want the answer as a number. So I just got to do this. I just gotta do the following. 122 divided, and I'm gonna use the division sign, by 9. Okay? So division by 9 and I get my number. So the answer is 13.5. Okay? So the mean is 13.5. Oh, okay. Now let's talk about the other one that is being asked of us, the median. The median is the middle number. The middle number when your data is arranged from least to greatest. Okay? So that means I have to arrange this from least to greatest. All right, the lowest number here is 13. So, okay, 13. Then 13. Okay. Then 13. Okay, then 13. Okay, then 14, 14, right? 14, 14, and then 16, 18, and 21. So 16, 18, and 21. All right, now let's see which one is the middle number. Well, how many numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's see now. 1 here, 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 1 here. Okay, and guess what? There goes the number in the middle, 14. So the median is 14. Okay, now I usually don't cancel out like that. All I have to know is that if the number is 9, there have to be 4 here, 4 here, that makes 8. So the ninth number should be in the middle. All right, the mode. The mode is the number that repeats the most. Actually, let's just look at this data right here to see which number repeats the most. 1, 2, 3, 4 13s. Nothing else has 4 numbers, okay? So therefore, the mode is 13. The range. The range is, and you can write it down, the largest number minus the smallest number, the maximum minus the minimum. So let's see. The range will be 21 minus 13. And what is 21 minus 13? Okay, you don't need a calculator for that, right? Right, 21 minus 13 is 8. Boom, you got that. And that is how you do the mean, median, mode, range. Let's try one more problem, not because I don't think you understood it, but because there is another type of situation with the median. All right, the mean. The mean for 1, 2, 4, 7, 1 plus 2 plus 4 plus 7, and everything divided by 1, 2, 3, 4. Okay, so 1 plus 2 is 3, plus 4 is 7, plus 7, 14. 14, okay, 14 divided by how much? By 4, right? Okay, so it's 3.5. Okay, now the median. In the median, you have to put the numbers in order. So median. This is the mean, this is the median. Median will be 1, 2, 4, 7. Oh, they were already in order. Okay, so look, cancel here, cancel here, cancel here, cancel here. We have a problem. We end up with no number in the middle. No, do not despair. Whenever you don't have a number in the middle, take the two middle numbers, okay, and find out what's between. What's between 2 and 4? 3, right? Or you could just, the easiest way that people teach is find the average of the two numbers. In other words, add them up and divide by 2. 2 plus 4 is 6. 6 divided by 2 is 3. So the median is still 3. Okay? And basically that's what I wanted to teach you. I'm not going to go through the range. I mean, I'm going to show you the problem. You could find on your own what the mode is. Now, you know what? Let's go. The mode here. Do I look like I have a mode? Is there a number that repeats? No. So, no mode. No mode. No mode. No mode. No mode. And the range is 7 minus 1. Okay. Okay, and that's it. Now, that's it. Now, I'm going to give you this problem. Okay, you're going to copy it and you're going to do it because you are interested in passing the Common Core Algebra Regions. All right, you pause it, you did it, and boom. Because I need to move on to something very interesting. Okay, hopefully you could see all this. Listen, we're going to be dealing with box and whisker plots. Box and what? Box and whisker plots. So what is that? Well, a box and whisker plot looks like this. The box, okay, the line, not in the middle exactly. Look, I'm going to give you 3 different scenarios of the box and whisker plot. These are different box and whisker plots, but they're all box and whisker plots, or box plots as they call them now in the Common Core. Okay, so how do you do that? Well, the box and whisker plot consists of several elements. For example, the first one is called the minimum. Then you have something called quartile. I'm going to write the whole thing. Quartile number 1. Then you have the median, which is also, okay, quartile number 2. And then you have quartile number 3. And then finally you have your maximum. And then you have something called IQR. It's called the interquartile range. Okay, I'm going to write it down. Interquartile range. And how do you find that? Easy. Once you found quartile number 3, you subtract quartile number 1 from it, and that is your interquartile range. This is called the 5-number summary. Okay, it tells you the spread of the data. How spread is all the data that we got. Alrighty. So the first thing is that if you ever hear mean, mode, when you're looking at box and whisker plots, that's wrong, because the box and whisker plots has only to do with the median. So let's take a look at our numbers. Let's go to our numbers and let's figure out our data. Alright, so this is your set of numbers. So the first thing, and please keep always this in mind, the first thing that you're gonna do is you're gonna find the median. What? Yes. So let's see. All I have to do is count the amount of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, look. The number of items is odd. It's 15. That means I could have 7, 7. Okay, 7, 7. And then whatever is left is in the middle. Okay, so 1, 2, 3, 4, 5, 6, 7. That makes, okay, that makes 10. The middle number, look, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we have the median. So we have found the median. What is the median known as? Quartile number 2. Okay then. So now what? Well, we need to go and search for quartile number 1. How do I find quartile number 1? Easy. You see the shape of the box and whisker plot? Well, let's do this over here. The median will divide your data into 2 sets. Starts looking like that, right? Yes. So now you have a, listen, box and whisker plots are all about medians. Now we're gonna find the median here. Let's see how many items. 1, 2, 3, 4, 5, 6, 7. Oh, 7. So I could have 3 here, 3 here, and this is my median. This median is quartile number 1. Now let's find the median over here. 1, 2, 3, 4, 5, 6, 7. So the median is 1, 2, 3, 1, 2, 3, and this is the median. See that? This is quartile number 3. Now we're lucky that the numbers are in order. If they were not in order, we will have to put them in order. Okay? So let's see. Quartile number 1 is 8. Quartile number 2 is 10. This one right here, because it's the median. Quartile number 3 is 17. Okay? The minimum is 5. The maximum is 19. See that? Okay. Now, where is the cover for this marker? Oh, right here. I found it. Thank you very much. And now let me change to another marker. Oh, okay. So now, the interquartile range. The interquartile range. Let me make this a little smaller. Kobe. Oh my God, my dog just lied down on the thingy that holds the camera. All right. Quartile number 3 is 17. Quartile number 1 is 8. So the interquartile range would be 17. Oh, beautiful marker. Doesn't write. 17 minus 8. Jesus Christ, like the dog ate it. It don't matter. I just write again. So 17 minus 8. Okay, so that's 9. Correct? Am I correct? Okay. So the interquartile range is 9. So that's it. I mean, that's basically how you construct a box and whisker plot. Now I'm gonna teach you the best way to construct a box and whisker plot, but please bear with me, okay? And once again, you need this calculator. If you don't get it, your life is gonna be miserable, okay? Look, so my data, this is how you do it. And please, you should write down the steps. The first thing you do is, when you have the calculator clear, okay, so press second plus, okay, and then we're gonna reset. So 7, then all RAM 1, and then yes 2, reset, so you press 2. So the calculator is reset, just in case. Now I'm gonna make the brightness a little more, so I press second and then I go like this. And you see, although it's gonna kill your battery faster, but so now listen to this. Press stat. Okay, and now you're gonna press enter on edit, and now you're gonna get your little columns. Okay, so this is L1, okay, L2, L3, L4, L5. So right now these are for different variables or for frequencies. Right now we're not dealing with that, we're just dealing with the data. So what you're gonna do is you're gonna press, you're gonna enter all the values. Okay, you know what the values are, but just in case, these are the values. Okay, so what I'm gonna do is, let me see if I can make it. Okay, I could see this, so that means you should be able to see it as well. Why am I talking to myself? All right, so look, 5, then you press enter. Okay, 6, enter, 7, enter, 8, enter, 9, 9, 9. Okay, then 10, then 12, then 14, then 17, then 17, then 18, 19, and 19. Okay, so you got all your values in there. So now you are going to press the key that reads stats again. You're gonna press stats again, stat. And what do you wanna do? You wanna go to the right. And you see the first thing that says right there, it's one variable statistics. You're gonna click enter on that. And now the calculator, if it's not this calculator, forget it. You're gonna have to enter other some other commands. But if it's this, the TI-84 plus C or the TI-84 plus CE, then it will give you a nice menu. So it says your list. Where did you put your list? I put it on L1, so it's by default there. Press enter. It says, do you have a frequency list? Right now, don't worry about it. You don't have a frequency list. Okay, so you just press enter. Then it says, do you really want me to calculate this? Well, got you again. So you say, yes, I want you to calculate. Press enter. So now the calculator is gonna throw to you some weird numbers. And now I need you to pay close attention. You see this X bar? I'm gonna zoom in. You see this X bar? This is your mean, your average. Wait, what? Yes, the calculator gives you the average. Look, it added all the numbers and divided by the amount of numbers, and look, 11.93. This is the sum. This is sigma, capital sigma. So this means the sum of all the x's is 179. In other words, if you add them all up, you get 179. If you square each of them and add them up, you get 2,481. Okay. Then this is called the sample standard deviation, S of x. Then you see this? This is called lowercase sigma. This one is lowercase sigma. This is the standard deviation. What? Yes. N is the number of values. There are 15 values in there. There are 15 numbers. Yeah, okay. And then we start with this. Look at this beautiful part. It says minimum is 5. Yeah, we knew that. Let me see now. Oh, beautiful, like right here. Shh, shut the hell up. Okay, good. So the minimum is 5. Quartile number 1 is 8. What? Quartile number 1 is 8? Nah, wait. Yes. And then it says quartile number 2, which is also called the median, is 10. Then it says quartile number 3 is 17. And then it says the maximum is 19. Now, it's not going to give you the interquartile range because it gave you the quartiles. So you have to figure out the interquartile range. Okay? So now, with this in mind, now with this new skill, let's take a look at this number right here. These numbers right here. All right, basically what he's saying is that based on this data, okay, which is the correct box and whisker plot. So what you're gonna do is I want you to take a look at it and answer the questions. Okay, take like 30 seconds to look at it. Oh, okay. So it says which of these represents the data. So this question is the same as the previous one, okay? So keep in mind, what is the, okay, so this is the data that I input. And now let's see, what is the minimum? The minimum is 5. Okay, so let's take a look at each individual one. Is the minimum 5 over here? No. Okay. Is the minimum 5 over here? Yeah. Is quartile number 1 8? Yeah. Is quartile number 2 10? No. You see, it's right here. It's 14. So then this is not. This is not. Let's take a look at the other one. Is the minimum 5? Yes. Is quartile number 1 8? Yes. Is quartile number 2 10? Yes. Is quartile number 3 17? Yes. Is the maximum 19? Yes. So then, therefore, you have answered the following question. This is your answer. Gotcha? Okay. Cool then. I think that now we are ready to go back to the regions problems, okay? Woo! Okay. So, let's go back to this one. Christopher looked at his quiz scores shown below for the first and second semester of his algebra class. So semester 1 and semester 2. Which statement about Christopher's performance is correct? So look, the interquartile range, the mean, the third quartile. So guess what? Calculator to the rescue! Hey, what's up with you? Okay. So basically this thing is about to go dead, but it's gonna give me enough time to show you how to do the problems. Alright, so basically to do this, I'm gonna put the data, or data, whatever you wanna call it, okay? So remember what I do? I press stat, edit, and now you really want to erase this because this is from the past problem. So what you're going to do is you're going to go all the way up to L1, okay? You're going to press clear, and you're going to, and look, everything is clear. All right, let's input the data for semester 1. 78, 91, 88, 83, 94, okay? And then I'm gonna input the data for semester 2. I'm gonna do everything at once. Although I don't advise for it, I advise for you to do it separate. But still, I'm gonna show you how to do it at once. 91, 96, 80, 77, 88, 85, 92. Okay? Now remember something. This calculator is allowed on the regions. If you have it, you must use it on the regions. Don't let nobody else tell you because that's illegal. This is allowed on the regions. So now, I am going to start with semester 1, which is I put in L1. All right? So let's see what's up. Boom, boom, boom. Now let me go inside. Okay. So now you're going to press stats again. You're going to go and calculate. Now watch this. It says, where did you put the data? I said I put it on L1. Do you have a frequency list? No, I don't have a frequency list. Frequency is how many times each event happened. You don't have that. Okay, so enter, and calculate. So now it's telling me the following, that the mean is 86.8. Okay, so I am going to basically, I need to write down the information that I have. Okay, it's not like I can just, you could actually read it from the calculator, but you still have to write it down. So I'm gonna write it down over here. So my mean, okay, my mean is 86.8. My average is 86.8. What else do I need to know? Okay, the minimum is 78. Quartile number 1 is 80.5. Quartile number 2 is 92.5. No. Quartile number 2 is the median. Sorry, the median is 88. You know, I'm gonna write over here 88. Okay. Quartile number 3, I am going, since you're doing it with me, is 92.5. Oh, okay. So, and the maximum, I don't know, the maximum is 94, but I don't know if I need that. Alright, the maximum is 94. That, my friends, is for semester number 1. Semester number 1, okay? Now let me calculate semester number 2. Remember something, I had already inputted the value, okay, the data into that. So I'm gonna press stat again, I'm gonna press edit, I'm gonna go back to the table, and this time I'm gonna calculate, I'm gonna go again and then press, look, I have L2 right here. So I'm gonna calculate that semester 2. I wanna calculate, so I go to the right, calculate one variable statistics, and now instead of L1, I'm gonna show you how to do it. You wanna change L1, you can press clear, right? You're gonna press second. You're gonna press second, and here you will see the list of all the L's: L1, L2, L3, El Chapo. Anyway, all that. So then L2. So I put L2, and look, I have L2. Now I press enter, and now it's gonna give me the values for the second semester, which I had inputted in L2. So I am going to basically just write down the information. So let's see now. The average is 87. Quartile number 1 sorry, is 80. I'm talking too much. Quartile number 2, or median, is 88. Quartile number 3 is 92. Okay, I'm not gonna go into any more details because my throat is becoming dry. All right, so let's see now. Information. Semester 2. Let's look at the information that we have. You wrote down the information. I hope. If not, you're gonna have to rewind this. It says the interquartile range for semester 1 is greater than the interquartile range for semester 2. So let's find out. Let's find what the interquartile range are for each semester. So IQR, interquartile range for semester 1, will be Q3, okay, minus Q1, which is 80.5. The IQR for interquartile range for semester 2 would be, okay, Q3 minus Q1, so that will be 92 minus 80. Okay, so let's find out. So 92.5 minus 80.5 is 12. Okay, 92 minus 80 is 12. So both interquartile ranges are the same. Okay, so you know what? One is not the answer to our questions. Let's read the second one. It says the median score for semester 1, okay, is greater than the median score for semester 2. So let's look at the medians then. The median score for semester 1 is, you know, Q2, right? This is the median. The median score for semester 1 is 88, and for semester 2 is 88. So no, it's not greater. Okay, the mean score for semester 2 is greater than the mean score for semester 1. Let's look at the mean, the average for semester 2 is 87. Is it greater than the one from semester 1? Yes. So we have our answer. Where the mean score? Okay. Let's look at the last choice just for the sake of doing it. The third quartile for semester 2 is greater than the third quartile for semester 1. Okay. The third quartile for semester 2 is greater than the third quartile for semester 1. Is it true? Nah, it's B. Lies. Anime is lies. All right then. So now, let's move on to our next example. That was somebody using the oven. I don't know who it was, but it doesn't matter. Don't hate on me because I got food in my house. Okay, so this one, oh my god, this is a long, but let's see now. You're used to this, now you're gonna have to read from far. Okay, good. Okay, so let's see now. Corinne is planning a beach vacation, right? In July, and is analyzing the daily high temperatures for her potential destinations. Okay, she would like to choose a destination with a high median. What? With a high median temperature and a small interquartile range. Okay, so here we are. I'm gonna have to teach you again. Okay, these examples are not a good thing. Let me give you a better example. Okay, so let's say you have this. And you have that. Okay, this right here is going to have a smaller interquartile range than this right here. If this is 0 and this is 100, right? Yes? No, let me see. If this is 0 and this is yeah, well, this is going to be 0 and this is not going to get to 100. This is going to be like maybe 50. Okay, it's smaller. In other words, the more spread the data is spread, then the higher the interquartile range is. Here, the data, you could see that it's everything together. So it's good, very good. Oh no, spread out, not good. Basically, that's what it is. So then now that we are understood on that, let's take a look at this. Oh, okay, these are very small. So what I'm gonna tell you, what does she want? She wants I don't know what she wants. She wants the high median temperature and a small interquartile range. So she wants high temperature. All right. So if we look at this, the median is always the little thing inside the box. Okay, doesn't matter where it is, in the middle or on the sides, it's still the same thing, right? So if she wants a high median temperature, definitely Ocean Beach is not a candidate, because look at the median temperature. It's like 76, 75. This is not about accuracy, it's about estimate. Oh, look at Whispering Palms. Damn, median temperature is like around 86. So I have a candidate. So this could be a candidate. Now let's take a look at the interquartile range. The Q3 is around 94. Okay, 94. I think that's what it is. 94, and the Q1 is around 84. Okay, so 94 interquartile range is what? Q3 minus Q1. So 94 minus 84 is 10. So let's say that the IQR here is 10. Okay, but guess what? I also have another candidate here. Okay, definitely Serene Shore is not a candidate. Look at the median temperature, around 76. No way. So the two main candidates are Whispering Palms and Pelican Beach. Okay, so what is the high temperature? The median temperature is 85. It's less than the Whispering Palms, which is like around 86. I know it's 85 is right here. Okay, so this one is winning by the temperature, the median temperature. But let's take a look at the interquartile range. The Q3 here is around 86. Okay, Q3 here is around 86. And Q1 here is around 83. So the IQR is 3. So high, medium temperature, and low, very small interquartile range. Okay, you have to have high and small. So then, which one will be your temperature, your beach? Well, I will choose Pelican Beach. Good. So Pelican Beach. Oh, it's not one of the choices. No, I'm just kidding. It is one of the choices. All right. So we're doing good. Oh my God. Ha. I'm awesome. Becca, you're awesome. Of course you're awesome. Son of the sky. Okay. Hey, stop moving my camera. All right. So let's move on to the next example. Or actually, you know what? Let me stop right here. And we'll continue when I take a break. Okay? Cool. Bye. Okay. All right. So let's continue with this Regents prep thingy, right? Okay, in this question, it says, Noah conducted a survey on sports participation. He created the following 2 dot plots to represent the number of students participating by age in soccer and basketball. So now you know what a dot plot is. Ha! Nice, right? So this is what it means. All right, so we have the soccer one here, and we also have the basketball. So look at the choices. In multiple choice, it's easier to just look at the choices and then analyze the problem. So here it says the data for soccer player are skewed right. The data for soccer players have less spread. All right, so let's go with multiple choice and let's look at them. The first one says soccer is skewed right. Does this look like the soccer players? The data is to this. Most of the data is on this side to the right. No, right? So that cannot be the answer. The next one. The data for soccer players have less spread. Are you kidding me? These soccer players are all over the place. They have more spread than the one from basketball. Oh, okay. I'm getting this. 3. The data for basketball players have the same median as the data for soccer players. Oh gosh. So that means that you have to find the median. How do you find the median? Well, is the middle is the number in the middle. Okay? Not 6, 7, 8, 9. Not this, but all together. So for example, you have 3 players, okay, that are 6 years old. 1, 2, 3, 4. 4 players that are 7 years old. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18. Here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you have the same amount of players on both sides. Now you have to find the median. Well, we know that there are 18. Okay? So the median will be, well, you have 18, the median will be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's around 8 years old. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's at 10 years old. That is BS because they don't have the same median. Let's look at the last choice. The data for basketball players have a greater mean than the data for soccer players. You know what? Enough of this. When they talk about median, mode, and you know how to interpret these things, then let's just use the calculator. So let's basically use the calculator. If it still works. Look, it's dying. It says charging the calculator is recommended. I don't care. So what you're gonna do is the following. You're gonna press the stats key again. That's your favorite friend right now for statistics. You're gonna press enter. So I already put in the data, so I'm gonna show you. Here there are 3 players that are 6 years old, 4 players that are 7 years old. That's basically what it means. So what I did is the following. I took the data, right? And we're talking about the data on soccer players. So what I did is I put the ages 6, 7, 8, 12. And then 3 frequency. In L2 I put the frequency. That means how many of something is happening at that situation. So the 6 years old, there are 3 things happening, 3 players. Okay? Then 4 players at 7. 2 at 8, 2 at 9, and blah blah blah. Then what I did is on L3 and L4 I put the data for the basketball players. So the ages and then how many of them, the frequency, how many of them. Okay, so now what I'm gonna do is I'm gonna calculate. Let's start with the soccer players. Soccer players is L1 and L2. You see, now I'm using frequency. So what I do is I press stats. I go to calculate and I press enter. So it says list of L1 of L list. What do you have your list? Well, I want to calculate the ones for the soccer players first. So I'm gonna put L1. I already taught you how to put L1. If you need assistance, then rewind the video, or if you're my students, then just ask me. And this is for L2. Now calculate. So the mean is 8.6667 or 8.67. So you write it down, correct? Now let me calculate. Oh, by the way, the median. Let's look at the median. Look, the median is 8.5. Let's now look at the second set of data. So you press stats, edit, and you see the ones for the basketball player I put in L2 and L4. I'm sorry, L3 and L4. What? Man, I'm going blind with this thing. Okay, L3 and L4. This is the age and this is how many, right? So now I'm gonna press stat again. I'm gonna move to the right to calculate one variable statistics. And now instead of L1 and L2, I'm gonna use L3, okay, and L4, which is where I put the data. And now I'm gonna calculate. And now you could see something. The mean here is 9.8. But let's look at the median. Okay, the median is 10 right here. You see 10? So that's why the medians are not the same. But anyway, the mean is 9.8. So now look at the last choice. The last choice says the data for basketball, okay, has a greater mean for a greater mean than the data for soccer players. Well, this is the data for basketball and this is the data for, this is the mean for basketball and this is the mean for soccer players, which I got from the calculator. We know that the basketball is greater than the soccer. So therefore, choice number 4 is the correct choice for this. Got it? Good then. All right, let's move on to the next problem then. Yeah, oh my God, I hope this is not gonna take that long. Oh my God, so many papers I have here. Okay, here we go. So, it says, 2 sets of data below represent the number of runs scored by 2 different youth baseball teams over the course of the season. So you have Team A and Team B. Then it comes the question, okay, which set of statements about the mean and standard deviation are true? Okay, now we're talking about standard deviation. So I'm gonna show you what it means, so you be prepared. Okay, so we're gonna press stat and then enter because we got sets of data. Kobe. Oh my God, look at this. Look at this homie right here. Let me see, can I? Kobe, where are you? I want to look at you. No, not eating the paper. Not eating the paper. What's wrong with you? Get down. Get down. Get down. No. Get down. Get down. Good job. Okay. So now we go back to basics. How do I do this? I don't know. Okay, it doesn't matter. So I just wasted like 30 seconds of my beautiful time. All right, so I'm gonna show you how to do this. So remember what I told you? Okay, so you have this calculator, and the first thing you want to do is you clear. So clear, go back down. Go up, highlight the column, clear, go back down. Highlight the column, clear, go back down. Highlight the column, clear, go back down. Okay, now we got everything clear. And what I'm going to do is I am going to notice that there is no frequency. It doesn't say team A got 4, and for every 4 he got 3, or for every 8 he got, no. It's just team A and team B. These are two different situations. You have to understand that. Okay? You have to understand when to include the frequency and when not to include the frequency. Okay. So, for team A, I got 4, 8, 5. Okay, 4, 8, 5, 12, 3, 9, 5, 2. For team B, look, I'm gonna put the data on L2, okay? For team B, I got, Kobe, don't eat the camera, thank you. You got 5, 9, 11, 4, 6, 11 again, 2, and 7. Okay, so now I got team A and team B. Okay, they were talking about standard deviation. They were talking about, let me see what the choices are. They're talking about standard deviation, and they're talking about the mean, talking about standard deviation, the mean, standard deviation, the mean. Oh, okay. So then I need to calculate all of that in the calculator. But it's the same process. Okay? So what you're gonna do is you're gonna do the following. So you're gonna press stat, you're gonna go to calculate. Every time they're doing this about the mean, median, mode, you're gonna do one variable statistics. Now, where did I put my data? I put it in L1, so I'm just gonna do L1. Now in L2 I put team B, so I'm not gonna combine team A with team B. So look, clear. There's no frequency list. So L1. I hope you understand this. Good. The mean is 6. Okay, so I'm gonna write it down. And my friends, this right here, and I'm gonna really emphasize this. This is the mean, and this is what you call the standard deviation, sigma x. The standard deviation is 3.1. Okay, so I am going to write it down over here. So for team A, okay, so I'm gonna call it AX. The mean for AX is 6. The standard deviation for X is going to be 3.1. Okay? Yes. Now let me go with team B. Okay. I haven't done team B, so I'm gonna do it over here. Once again, you go to stat. You're gonna go to calculate. You remember that we already input the data. Where did we put the data? In L2. So you press second and the number 2. And now calculate. So now we have the mean and we have the standard deviation right here. So I'm gonna write it down. The mean is 6.87. The standard deviation is 3.0. Now let's talk about the choices that we have here. Okay. It says the mean of A is less than the mean of B. Yes, it is true. The standard deviation of A is greater than the standard deviation of B. The standard deviation of A is greater than the standard deviation of B. Wow, are you kidding me? That was easy. Okay, that was easy. The mean of A is less than, this is less than, right? Less than the mean of B. And the standard deviation of A is greater than the standard deviation of B. Yep. So now you understand. Now, what is standard deviation? I'm just gonna tell you like in plain words. The standard deviation measures normality. Like, for example, how far is the data from the mean? For example, this is something called the bell curve. You're gonna see that in algebra 2. This, in the middle of the bell curve, you have something called the mean, the average, right? So these, my friends, are called standard deviations. How many standard deviations? 1, 2, 3, 1, 2, 3, doesn't matter, okay? but it's how far is the data from the average, the mean. That's what it means. Okay? Got it? Okay, let's move on. Oh gosh, I have more here. Okay, no problem. So, next problem. Hopefully you'll be able to read all this. Oh, okay. So it says, Isaiah collects data from 2 different companies, right? Each with 4 employees. The results of the study based on each worker's age and salary are listed in the table below. Okay. So what does that mean? Well, they're listed, yes. So, now you have seen the data, okay? Look, this is that data. You can look at it all you want. Take a picture, pause it, however you want to do it, but you need to keep it in mind. Now, let's go on to the multiple choice statements. So, the first statement, it says, the median salaries in both companies are greater than 37,000. The mean salary, okay, mean salary range, the mean age of workers at company 1 is greater than the mean age of workers at company 2. Oh gosh, the mean age. Okay, so what we're going to do is, first of all, what is the important part? They're talking about that this guy collected information on 2 different companies. And in the multiple choice, you're looking at salaries. Okay, so let's talk about salaries first, and then we'll talk about the last choice, which is the mean age, the average of the ages. Okay, so what am I gonna do? I'm gonna call my favorite friend, right? And I'm gonna say, okay, let's press stats again. You see, favorite friend, stats, I said. Okay, good. So we're gonna press stat. I don't need this data, so I'm gonna go up and clear. Go down. And I am going to start inputting the data from the workers, okay? Now, I don't think it makes sense to put 25 years old, 30, 27 years old, 32. No. They're talking about who makes more money, who's the average. So what I'm gonna do is I'm gonna do this. 30,000, 32,000, 35,000, 38,000. Okay. On L2, I'm gonna put company B. So 39,000, 35,000. Oops, no, 35,500. Okay, we're talking now. 37,000, 65,000. Nice, I'm gangster. Oh, nice. So 65,000. All right, so L1 and L2. Now let us go with the first company. So I'm gonna calculate the statistics. I know I put the first company on L1, so I press second and then the number 1 and boom, boom, boom. Okay. So that's what I have. So I'm gonna copy it down, right? The average is 33,750. Okay. The median, I have no idea, is 33,500. Okay. The range is the maximum salary minus the minimum, so it's gonna be 65,000. No, we're talking about the first one, right? Sorry. Okay, 38,000 minus 30,000. Okay, now let me calculate the things for B. So I'm gonna press stat, right? I'm gonna go to the right. I'm gonna try to calculate, but this time the data that I put for company B is on L2, so I'm gonna press second and L2 and enter. So now I have I have an average for company 2 of $41,625, a median of 36,250, okay, in a range of 65,000 minus 29,000. Okay. Okay. So, anyways, let us analyze the data. So, you don't need the calculator. You need to see the calculator anymore. I got the data right here. So let's analyze. The median salaries in both companies are greater than 37,000. The median salaries are they greater than 37,000? Hell no. That means they don't get paid enough. So this is not the answer. The mean salary in company 1, okay, is greater than the mean salary in company number 2. Yeah, sure, right, greater than this. No, it's not so. Okay, the other one. The salary range in company number 2 is greater than the salary range in company number 1. Well, let's see. What is the salary range? The maximum minus the minimum is 8,000 in company 1. In company 2, we have, okay, 65,000 minus 29,000, right? And how much is that? The range is 36,000. So the mean age of workers in company 1, okay, I'm sorry. I'm talking about this one. The salary range in company 2 is greater than the salary range in company 1. Hell yeah. So then choice number 3 is the right one. Get that? All right, cool then. So oh wait, hold on. Got you. Alright, let's move on to the next question. I'm getting tired of this and I'm losing my sight, so I cannot see too well. Alright, so let's see now. Can you see this? Come on, move. Not like that. You know what? I'm gonna have to read it because this is becoming very small. Okay, anyways, you could actually see it. So this table shows the annual salaries of 24 members, right? Of the professional sports team in terms of millions of dollars. I wish I had one of those millions, but anyways. The team signs an additional player to a contract worth $10 million per year. Which statement about the median and the mean is true? Alright, now let's get a close up and let's see what in the world is true. So that's what they're saying. Which one of this is true? Well, let's see. Which statement about the mean is true? Both will increase. Oh, what statement about the median and the mean is true? Both will increase. Only the median will increase. Only the mean will increase. Neither will change. Well, let's see. The team signs an additional player, one more player, to a contract worth $10 million. Oh my God. Alright, the first thing I'm going to do is the following. Although I could do it by hand, I don't want to do it by hand. You know, I'm going to call my favorite friend, right? The calculator. So I'm going to input all the data that I see in there. Okay, let's see now. Clear. All right. Stats. Clear. Oh, okay. So I'm going to input the data. So I am at 0.5, 0.6, or 0.6, whatever you want to call it, 0.7, 0.75, 1.8, 1, 1, 1.1, 1.25, 1.3. This is tedious. I hate this. Oh my god. 1.4. You know what? I should be having fun right now instead of doing all this. But anyways, this is what's called responsibility. Beker, stop talking and just keep on working. No, man. Come on. Are you kidding me? Look at all this crap that I have to do. Okay, 4.2. And if I write a negative number, I'm gonna kill myself. This is too many numbers. 5.1, 6. Yo, this guy makes $6. I mean $6 million. Damn, a year, right? And I am only making a couple of thousand, and I have to work more and teach everybody. Okay. Anyways, so I got all the numbers. Now I'm gonna calculate everything. Stats, calculate. Okay, where did I put my information? In L1. Okay, so this is the information. Now I am going to talk about the median. Okay, this is the team size, blah blah blah. Which statement about the median and the mean is true? Both will increase. I don't know. Let me write down the mean. So the mean is 2,005,625. The median is 1.4 million. Okay, that's all I needed to know. Now, they signed an additional player. So what I'm gonna do is I'm gonna go press stat, I'm gonna go to the table, and they say they signed an additional player, right? They signed an additional player. So let us go back here. They signed an additional player to a contract worth 10 million. Okay? 10 million. Well, this is 6 million, so 10 million must be a 10. So what I'm gonna do is I'm gonna add this guy and I'm gonna put a 10 in here. Okay? So I just added sorry, an additional guy with $10 million. Let's see what happens. So once again, I'm gonna press stat and calculate, and I'm gonna go to one variable. Where's my data? In L1. Now calculate. Let's see now. The mean, definitely it changed. The median, yo, this calculator's OD. Look at the median. It's still 1.4. Boom. So only the mean will change. No way, this is OD, this is OD, OD. Okay, stop wasting time. Alright. It seems like I'm going to, let me see what's next. I did number 9. Wow. So the next one is number 10, and we only have 440 problems to go. Wow. Alright, so I'll see you on the next episode of How Do We Pass the Common Core Algebra Region.